Greetings and welcome to my new calculus channel. My name is John Gabriel. And today I'm going to be talking about proposition 13 of book 5 of Euclid's Elements, which follows immediately on proposition 12, which is the most important proposition in Euclid's Elements. So let's begin. Now, just a quick recap. Remember, I showed you in the previous video how you can do all the operations of arithmetic, and I gave you an example also with taking the product of 6 and 3/2 using quotients, because in actual fact multiplication is just a reciprocal measure of one number by the other, and it requires that division has already been established. So either of these two must be inverted, and since there is no zero magnitude, I didn't show you the second example, which is by inverting the ratio 3/2, okay? But ultimately you get the same result. So using algebra, we say that P over Q multiplied by R over S is possible if and only if both P over Q divided by S over R equals R over S divided by Q over P, which means this proposition rules out any division by zero in any of the arithmetic operations. Okay, so you cannot decide, as modern math academics do, that multiplication works one way and the other way it doesn't work. It has to work both ways, because that's what it means in geometry, and it was transferred from geometry to algebra. So I mean, you wouldn't be able to invert this here, you wouldn't be able to invert this part here if R was 0, right? Or if S was 0. Okay, do you see? So that's why you cannot have 0 as a true number. It's not a true number, and you have to be very careful when you are working with 0. Because 0 is really just a placeholder. Okay, so that's the recap. What does proposition 13 say? So again, Heath gets into a problem with language here. So I can't say, excuse me, I blame him entirely, because Greek is a polymorphic language, and the word that is used in proposition 13 is meizona, which actually means major, but in many other texts that it's used, it means greater than, okay? Now, modern Greek is a little bit better than ancient Greek in this respect, because we have two terms that can be used instead of mείζονα. And the one term is υπερβαίνει, so we can say 4 υπερβαίνει 3, which means 4 exceeds 3, or 4 είναι μεγαλύτερο από 3, which means 4 is greater than 3, okay? So in this proposition, mείζονα does not mean greater, okay? It means that the measure of the ratio is greater, not the ratio itself. Remember, I told you that no ratio can be greater or lesser than any other ratio. We can only talk about ratio trichotomy with respect to the measure of ratios. Okay, so I'm giving you a glimpse into the brilliant minds of my ancestors by revealing these things to you. Okay, neither Heath nor any other moron of mainstream mathematics academia actually understood these things, or even understood the elements per se. They had no clue. In fact, you can ask any mainstream professor if he can give you a definition of number, and the idiot, no doubt, whoever he is or she is, will not be able to give you a definition, because they have no clue what is a number. Okay, so given any two ratios, P in relation to Q and R in relation to S, only one of two things are possible. They are either equal or they're not equal, okay? The ratios may or may not be proportional to each other. If they are equal, then the implication is that they are also proportional. However, they can be proportional without being equal. So what proposition 13 tells us is that if ratio alpha to beta, or alpha to beta, is proportional to gamma to delta, then the measure of gamma to delta is greater than the measure of epsilon to zeta. Then if it's greater than that measure, then the measure of alpha to beta is greater than the measure of epsilon to zeta. And I give you an example here. And in this example, I purposely left out the numbers so that you can do that as an exercise later on to see that what I'm telling you here is true. I have color-coded it to make it easier for you. So you can see that if you have 9/12 proportional to 3/4, then the measure of this ratio is greater than the measure of this ratio, whose measure is a half, right? 3/4 is greater than a half. So it's very easy to see that Thomas Heath did not understand these details. He missed all this information, just as the ignorant morons of the last 2,000 years in mainstream academia, mathematics academia, have also misunderstood almost every core concept of Euclid's elements. In fact, the arrogant fools thought they knew better, and I can't tell you how many idiotic mainstream math PhDs have written books claiming that the Greeks didn't actually know what they were doing. The truth is, those fucking morons didn't know what they were doing. So, sorry I couldn't resist using that language because I have such a deep disdain for mainstream mathematics academia. I consider a lot of them to be a bunch of incorrigible idiots. So I'm going to be continuing with the following propositions. Be sure to become a subscriber if you're not one already. Click like and spread the news of this wonderful channel. I am revealing knowledge to you that no one could reveal to you in the last 2,000 years, or certainly no one after Euclid could reveal to you. I'm giving you a glimpse into the minds of my brilliant ancestors, the ancient Greeks. Now, modern Greeks are a bunch of morons compared to the ancient Greeks. And even though I'm 55% Greek, I consider myself smarter than a lot of them because a lot of them had been simply indoctrinated and brainwashed by the Western universities where they graduated. So modern Greeks, for all intents and purposes, are also a bunch of morons who don't know any better than Western mathematics academics. So I'm going to leave you with this now, and I'll hopefully be in touch with you soon. My name is John Gabriel. This is a new calculus channel. Till next time, goodbye.